two projects. In this video, we are going to explain about the project title Classifying Malicious User Requests in the Network Using Deep Learning Models. Before diving into the execution, let me give you an overview of the project. As the internet and digital services have become more widespread, there's been a huge increase in the amount and intricacy of network traffic. However, this surge has also led to a troubling uptick in harmful activities like hacking, phishing scams, DDoS attacks that flood websites with too much traffic to handle, and data breaches where sensitive information is stolen. Traditional rule based and signature based security systems are becoming less effective due to the evolving nature of these threats, which often employ advanced evasion techniques to bypass conventional defenses. The primary aim of the project is to detect whether a user request within the network is malicious or normal. By accurately classifying these requests, the system helps in proactively identifying and mitigating security threats, thus enhancing overall network security. The project utilizes linear regression, Navy Base, XGBoost, and convolutional neural network to classify malicious user requests in network traffic. While each method has its strength, XGBoost's superior performance led to its deployment in the front end for effective identification of malicious requests, thereby enhancing network security. The project benefits network administrators with improved monitoring tools, businesses with enhanced data protection, and end users with safer online experiences. Additionally, cybersecurity researchers gain access to a framework for developing new threat detection techniques. To implement this project, we need software and hardware requirements. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Algorithms used. These are the algorithms built in the project, which are linear regression, Navy Base, XGBoost, that is extreme gradient boosting, and convolutional neural network. We have built all these algorithms to compare the performance with different evaluation metrics like accuracy, precision, recall, and FN score. And here, the XGBoost outperformed the other algorithms, and that is the reason we have deployed it in the front end. Now, let us execute the project. To execute this project, first we need to open the code folder, which contains the project source code files. So, here, this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, and more, which represent different pages of the website. And here, this is the dataset folder. Let us open this. So here, these are the parameters: unmanned, UID, origin P, response H, response P, flow duration, FWD packet start, and many more. So these parameters represent various attributes extracted from network traffic flow data, including source or destination details, flow duration, packet counts, payload and inter-arrival time statistics, subflow metrics, and traffic categorization. They serve as crucial features for models aimed at discerning malicious user requests from normal network activity. So here these are the features. So this data set is pre-processed and then it is used to train the models. And here this is the target column in which we are having two labels, 1 and 0. 1 is for malicious user request and 0 is for normal. Now let us close the data. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here, this is the model file, which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. And here we have the test cases text document. Let us open this. So here these are the test cases which we will use during the execution. First, we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. So if we are new users, we need to register first. So click on sign up link here. So here we need to enter all these details to register. But I have already registered. So click on sign in button. So here we need to enter the username and the password, which are static, and then click on login button. We have logged in successfully and we are redirected to the prediction page. So here we need to enter all these parameters value, and after entering the values, the application will predict whether malicious user request is detected or not. Before entering the parameters, let us understand what the parameters are. So the first one is backward initial window size. The initial window size for backward traffic flow, indicating the maximum segment size for data packets sent from the receiving end to the sending end. And the next one is backward header size maximum. The maximum size of the backward header, which includes information about the packet source, destination, and other metadata. Forward packets payload. The payload size of forward packets representing the actual data being transmitted in the forward direction. Backward header size minimum. The minimum size of the backward header providing information about the packet source, destination, and other metadata. Forward packets payload maximum. The maximum payload size of forward packets indicating the largest amount of data transmitted in the forward direction. Backward bulk rate. The rate of bulk data transfer in the backward direction, typically representing large volumes of data being transmitted. Flow RST flag count. The count of TCP reset RST flags observed in the network flow, indicating attempts to reset the connection. And the next parameter is flow SYN flag count. The count of TCP synchronized SYN flags observed in the network flow, indicating the initiation of a connection. Flow FIN flag count. The count of TCP finish FIN flags observed in the network flow, indicating the termination of a connection. So these parameters provide insights into various aspects of network traffic behavior, such as packet size, header information, and flag counts, which can be valuable for identifying patterns associated with normal or malicious activity in the network traffic. Now let us enter the parameters value. from the test cases. So here, these are the test cases which I have shown you during the execution. So from here, let us enter the value. So let us enter this set of parameters first. So here, the first one, backward initial window size is 65160. Backward header size maximum is 44. Forward packets payload is 221.3392. Backward header size minimum is 32. Forward packets payload maximum is 745. Backward bulk rate is 0. Flow RST flag count is 2. Flow SYN flag count is also 2. Flow FIN flag count is also 2. So here I have entered all the values. Now click on submit button to get the prediction. So here we can see the outcome, that is malicious user request detected. So we can see that it is a malicious user request from the information which we have provided. Now click on try again. Let us enter another set of parameters to see whether it is malicious user is detected or not. So again, from the test cases, let us enter the value. Now let us enter this set of parameters. So here backward initial window size is 65160. Backward header size maximum is 40. Forward packets payload is 76.3000. Backward header size minimum is 32. Forward packets payload maximum is 301. Bulk rate is 0. Flow RST flag count is 6. Flow SYN flag count is 2. And flow FIN flag count is also 2. So here I have entered the values. Now click on submit button. So here we can see the result, that is normal. It means no malicious user is detected. It is normal based on the provided information. Now let us enter on the set of parameters. Click on try again. So here I'm entering on the set of parameters from the test cases itself. So here let us enter this set of parameters. So the backward initial window size is 65160. Backward header size maximum is 40. Forward packets payload is 241.75. Backward header size minimum is 32. Forwards packets payload maximum is 746.87. Backward bulk rate is 0. Flow RST flag count is 2. Flow SYN flag count is also 2. Flow FIN flag count is 2. Here the So here I have entered all the parameters. Now click on submit button. So here we can see the result, that is malicious user request detected. So here malicious user request detected means that a system has identified a harmful or unauthorized action initiated by a user, signaling a potential security threat or breach. Now let us enter on the set of parameters. Click on try again. So again, from the test cases, let us enter on the set of parameters. So here this time let us enter the set of parameters. So the first one is backward initial window size is 65535. Backward header size maximum is 40. Forwards packet payload is 94.97. Backward header size minimum is 32. Forwards packet payload maximum is 301. Backward bulk rate is 0. Flow RST flag count is 3. Flow SYN flag count is 2. And flow FIN flag count is 2. So here I have entered all the parameters. Now click on submit button. So here we can see the result, that is normal. It means no harmful or unauthorized action is being detected. So in this way, just by entering the parameters value, we can predict whether malicious user is being detected or not. Now click on logout link here. In this project, we have built a system capable of detecting malicious users by analyzing network traffic behavior. We have extended its usability by integrating Flask to deploy it as a web application. Detecting malicious users early is crucial because it enables proactive defense measures, preventing potential data breaches, system compromises, and other security threats. This early detection helps mitigate risk, safeguard sensitive information, and maintain the integrity and reliability of the network infrastructure.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.